In last class we have discussed about substitutional frame method, that is in approximate method of analysis. Okay, substitution frame method is only for vertical loads. Now we are doing for horizontal loads. Okay, so for dealing with horizontal loads we have three methods of analysis, that is portal method, cantilever method and factor method. So now we are dealing with portal method of analysis. So this is a bay frame, multi-bay frame, two-story building. Okay, so at one story we have 90 kilonewtons and other story we have 50 kilonewtons. So in this portal method, first we are going to calculate these values of P. Okay, so P1, 2P1, 2P2 and P1, and P2, 2P2, 2P2 and P2. Okay, what are these P2s and P1s are actually? These are the column shears. Okay, due to the load acting on this member, that is on this frame, this story, there are some column shears developed with respect to each joint. Okay, sorry, each column. So these columns, for the external columns the column shear is P2, but for the internal columns it is 2P2. Okay, this is as per the method of analysis, please remember this. Okay, so first coming to the method of analysis, first at end we are supposed to transfer the horizontal loads to vertical loads, that is these loads will be converted into the column shears. Column shears will develop the moment about these joints, okay, with respect to each member, and the moments which are developed in the columns will be transferred to or balanced to beams with respect to the joint condition, that is equilibrium condition. Sum of moments about any point are equal to 0. Okay, or else sum of vertical forces is equals to 0, sum of horizontal forces is equals to 0. By considering these three equilibrium conditions, we are supposed to solve the equation and find the values of moments in columns. Then after that, from the moments whatever we have calculated, then we will be calculating the shear in beams or load which is acting on beams vertically. Okay, then first we will go for calculating the loads, that is the column shears. Okay, or the load in columns. So this load, as the floor is at the bottom story or the bottom floor will have the load from top and bottom as well, whereas this story, the top story, will have only load with respect to 50 kilonewtons, but for the bottom story the 50 kilonewtons as well as the 90 kilonewtons both will be active. So first we will calculate P1s, that is P1 plus 2P1 plus 2P1 plus P1 is equals to 90 plus 50, as we have seen here. Okay, so total is 140 kilonewtons. 6P1 is equals to 140, P1 is equals to 140 by 6, that is 23.33 kilonewtons. Okay, so P2 plus 2P2 plus 2P2 plus P2 is equal to 50 kilonewtons. That means 6P2 is equals to 50, P2 is equals to 8.33 kilonewtons. So here we have got the values of P1s and P2s. Now we are supposed to calculate the moments. So to calculate the moments there are two formulas. That is, basically we will be considering whatever the loads which are acting at center. The column shear is developed at center. Okay, so that will take it as, and next, so moments at the center of the column will take column into h by 2. Okay, column shear into h by 2, w into l by 2. Okay, basic formula. So the reverse process we will be doing to calculate the beam shear force, that is moment into 2 by length. That we will discuss when we go with respect to moments. So first process what we do is we are supposed to calculate the shears of columns. So already we have calculated the shears of columns, that is P1 is 23.33 and P2 is 8.33. so these values, P1 we have added 23.33 at the starting and ending, and at the intermediate we are supposed to double the P1 values, that is 46.67. okay, similarly for the members, that is 8.33 at the ends P2, and at the centers, that is internal, it is 16.67. after calculating this, now we are supposed to develop the moments. okay, so what are the moments which are there? Here we need to note one thing, that is if at a joint A, if we have a moment in one direction, that is in the external direction or in the clockwise direction, the other will be in the anti-clockwise direction. So the beam members will have the common moment and the column members will have the opposite moment to that. okay, taking this into consideration, we are supposed to develop all the forces, and that is sum of vertical forces is equal to 0 or moment about the joint are equal to 0. Here in this case we are supposed to consider. So first, how do we calculate the moments? okay, what is column moments at the joint of the column we will calculate as, for column EJ and HM, the column moments are, please take this as C. okay, EJ and HM are so EJ and HM are 23.33 into the column height is 5/2. Here we can, in the question it is given the column's height is 5 meters and 4 meters. For the bottom story it is 5 meters, for the top story it is 4 meters. Whereas for the beam distance, that is column spanning is 5 meters with respect to the first bay and 6 meters with respect to second bay and 5 meters again with respect to third bay. okay, so the same concept we are using, as the column height and the loads are of same with respect to EJ and HM. We are taking both the conditions, that is 23.33 into 5/2, which gives us 58.32. okay, these 58.32 we are supposed to represent in both the cases, HM and okay. Next, similarly for AE and DH, AE is nothing but the top story, that is the edges. okay, edge columns. AE is edge column with respect to left side and DH is the edge column with respect to top story and right side. okay, so that is 8.33 into 4/2. As we have seen just now, the column height is 4 meters for the top story, so the moment is 6.66 kilonewton meter. Next, interior columns, that is FK and GL. FK is the bottom interior columns and GL is the bottom interior column. So for that, the column shear is 46.67, that is 2P2 into 5/2, that is 116.65. okay, and DF and CG are the top story internal columns, so BF and CG. So for them, that is 16.67 into 4/2, that is 33.32 kilonewton meter. Next, beam shear force. Whatever the column moments we have calculated, that we are supposed to represent here. If you go for this, so what are the columns moments we have calculated, that moments we are supposed to represent here. So one, if the moment is acting towards inner, the other moment moves in upwards, that is clockwise and anti-clockwise. So in the similar manner, we are supposed to represent all the column moments at the initial stage. Okay, then after that we are supposed to give the beam moments. Okay, so how do we simplify these beam moments is, first we will take the joint A. Okay, if we take joint A, sum of moments about these joints are equal to what? That is MAB plus MAE is equals to 0, where MAB is unknown, which is the beam member, and MAE is the column member, which is known. So the moment with respect to MAB is minus 16.66, which is anti-clockwise moment. Similarly for joint B, so MBA plus BC plus BF, whereas BA and BC are the beams and BF is the column member. So as the moment here it is in anti-clockwise, here we will take as clockwise moment. Okay, so next there is 16.66 plus MBC minus 33.32, which is equals to BC is equals to 16.66 we have represented here, which is in anti-clockwise. Okay, and similarly for joint C it is MCB plus CD plus MCG is equals to 0, that is 16.66 plus MCD minus 33.32, where MCD is equal to 16.66, and M sum of moments about E is equals to 0, that is MEA plus EF plus MEJ equals to 0. Here for the bottom story joint, that is EA, EJ, EF and EA equals to 0. We know the value of EA and EJ, so sum of both will be the value of 17.98, that is the beam moment. And for that moment 9, sum of forces about F are equals to 0, sum of moments about F are equal to 0, that is MFE plus MFG plus MFB plus MFK is equals to 0, that is MEFE is 74.98 and MFG is unknown, so we are finding out, and MFB and MFK is equal to 0. So here we have columns, that is 116.65 and 33.32. So, and as just now we have calculated FE, so that is 74.98. From this we will get the value of, that is 74.98 as FG. Okay, similarly we will do it for G and same, the same values we will have it for G and F. So after calculating this, that is moments about B, from moments about G we will calculate the beam shear force, or the forces which are acting vertically on the beams. Okay, for that AB and CD are of same, that is having same height, 16 into 2 by 5 it is 6.67, whereas for BC it is 16.66 into the length of the beam is varying, it is 5.55. So EF into GH is 74.98 into 2 by 5, that is 29.99. Okay, next FG is 74.98 into 2 by 6, that is 24.99. okay, from this we will calculate the column shears, and this we are representing here, that is 6.66, 5.55, 6.66 and 29.99 and 29.99 over here and 24.99 over here. With this we will end the process. This is the portal method of analysis for vertical loads. So whatever the vertical loads or the lateral loads which are acting, that we are converting into the whatever the lateral loads which are acting, that we are converting into the vertical loads, and how the effect is happening on the beam, that we are representing. Okay, next we will go on with the factor method of analysis and cantilever method of analysis in next class.